zinc sulfide batteries, and nickel cadmium batteries. But of course, all these things, nickel cadmium and lithium ion are very latest. Started with zinc batteries, which we said dry cells, voltaic cells, we will call it. Afterwards, lead acid battery become the industry standard for any application, whether automobile, home, wherever electricity was needed. Before invention of this one, the batteries were used in 1600, 1700, till the generators or the DC generator invented, all those things. That's what. So DC, that means the DC motor uses DC power, which is called as unipolar power. Another name is called unipolar power. Unipolar power means we know that whenever you want to represent voltage or current in the universe, anything if you want to draw a graph, always with respect to time. We know that x-axis always will be time with respect. Generally, that depends upon voltage, current, speed versus torque, like that will be there. Generally, any quantity we measure with respect to time. At t start from 0, it goes up to infinity. If I plot the voltage of a battery V, I say that VDC or V battery without connecting to any load, you will see a constant voltage with respect to time. The voltage remain constant. For example, lead acid battery used in car, 12-volt battery means it will be 12 volts. We know that generally we represent the battery like this symbol plus minus. This is the symbol for battery, and it this one, and this is called terminal. One is called positive, negative terminal. If we connect to a meter, a voltmeter, and if you see the value, it will be showing 12 volts. It is a lead acid battery used in cars, or 12.1, depending upon the charge level. Generally, theoretically, we say 12 volt, fully charged condition. It can go up to 13.8 volts also. Maximum voltage that we will see when we talk about battery. So that means the voltage remain constant. You can see the height with respect to x-axis remain constant as long as I don't connect with your load. Okay. Now, if I connect with your load, load is nothing but generally represented resistor R. I say that R load, and this is my battery. It is a 12 volt. If I connect to a load having 10 ohms resistance, there'll be according to Ohm's law, I know I equal to V by R, where V equal to 12 volts and R equal to 12. So 12 divided by 10 will be 1.2 amps current will be flowing. The current value will be 1.2 amps. Now, if the load is my motor, it can be my DC motor. So the DC motor is going to, the load resistance or coil resistance is 10 ohms. And so the current is flowing, and because of the magnetic flux is created, and there are two such coils. So each coil you are supplying, this yesterday talk, there's a magnetic repulsive force is created. So that's how the motor works. Now, I told you, since these motors, all the DC motors are using unipolar power supply. Unipolar means with respect to time, the voltage is always one-sided. Correct? Y-axis, this is called positive, and bottom below this is called negative voltage. Correct? So if voltage remain constant, whether it is positive or it can be negative also. Please note that if I reverse the polarity of the battery, my voltmeter will show negative 12 volts. Correct? Negative 12 volts, constant. It is going to remain. So still this is DC. Whether positive or not, as long as voltage remain constant without variation, then we call it as DC voltage, direct current. Batteries are producing this voltage. If the voltage is given to a motor, that motor is going to produce torque and rotate at a particular speed. We call DC motor. That's what we are going to see now. And so actually there are 4 types. This type is now used in electric vehicle, automobiles. You are using brushless DC motor. In the beginning, we were using all these things some 100 years before, or even 50, 60 years before. Also, we were using. Even many times you see that old electric vehicle 20 years before also made a model, all those things, they may be using these series motors, but they are not very efficient. There are a lot of issues we will see when we talk about it. Okay, fine. Now that we want to discuss about the DC motor, and these 3 types first we'll talk, later we'll talk about brushless DC motor. Okay, now how the basically a DC motor works. I want to know what is a motor, because this is basic electric motor which invented first. After that, the AC motors. So if yesterday itself I told you that a motor consists of 2 electromagnets. It consists of two electromagnets. We know the electromagnets whenever electric power is applied, a magnetic field is created. This electric power applied to what? A coil. Note down. Correct? That means you take a wire and make it as a coil. Okay, and I supply voltage to this. I supply voltage V. Because of that, there's a current flow I, and the coil has resistance R, and it has n number of turns. Because of there's a current is flowing. If current is flowing in a coil, according to Ampere's law, magnetic flux phi, that is called as symbolic flux. Magnetic flux is created. Magnetic flux is created around the coil. For example, take a battery connected to a wire. I may use a different color. Of course, we know that the current will for this also wire only. I am talking specifically for understanding purpose. Take a long wire, which is represented here as a red color. Others also wires only. Don't use current will flow only to wires. For understanding purpose, we are saying this represent a motor coil. This part red color is coil. This one. That means there's a current flowing, and the current is flowing in the direction. Generally, current we know the start from power supply battery plus and goes into it and comes out. Circuit is closed by entering into minus terminal. Of course, inside the battery again, please note that this is going to circulate. The current is circulated. We call this as I. This current direction is called conventional current direction. Note down. It is called as conventional current direction. Okay. But actually, we know that I would have told in the previous class, current is nothing but flow of electrons from one terminal to another terminal. Actually, the electrons are generated in the negative terminal of the battery. Here only electrons are generated. Electrons are generated by a circle within that a minus sign. Okay. So actually electrons, these electrons are traveling like this. Correct? Through the conductor. This is the motor coil. I refer single coil or single wire motor. I will say that in which the electrons are flowing like this, and they come back to positive terminal, and once enter positive, they will become neutral. Again, the battery creates. This is my battery. Inside that you have electrolyte. The electrolyte will be split into positive or negative electrons. The negative electrons is accumulated at the negative terminal. Correct? Before, if I take a battery like this, positive and negative terminal, before if I don't fill the electrolyte, the positive and negative terminals are made of generally metals, metal electrodes. There are two metal electrodes. In lead acid battery, if you take it, one is called Pb, other one is PbO, lead oxide, another pure lead. One is positive, other one is negative terminal. And if you don't fill the electrolyte, generally it is diluted sulfuric acid in lead acid. If you don't fill, nothing happens. Today, tomorrow, you go and measure the voltage across the without electrolyte. In the battery factory, that's what they do. They make the battery casing, all this thing will build. They don't fill the electrolyte. They will send the batteries to the supplier where they are selling. Correct? And the supplier, I'm talking this nowadays, it is already pre-filled because this is a different type of battery. But basically, if I go to battery shop, that fellow will, once you place the order, pay the money, then he will fill the battery with the electrolyte. Electrolyte is nothing but 80 to 85% of water, pure distilled water. It should not have any contamination. And remaining 10 to 15% of sulfuric acid, correct? Pure sulfuric acid mix. Then it becomes diluted. That will be filled inside the battery. Actually, the electricity in the battery is produced by electrolyte. The electrolyte consists of, we know, H2SO4. We are going to see later. Sulfuric acid consists of H2SO. So this will be split into two parts. One is hydrogen, other one is sulfuric acid, SO4, correct? This hydrogen will be further split into H and plus E minus. correct? We know that the inside the hydrogen atom, one proton, one electron. There's no neutron in hydrogen, correct? And heavy hydrogen, you have neutron, but normal hydrogen, you have only one positive charge proton in center and an electron. So that is split inside the your lead acid battery. So this fellow, this is called as positive ion because it has a positive charge, proton lesson. This goes to positive terminal of the battery. The electron, which was split, removed from the hydrogen atom that will be separated, it has negative charge that comes and accumulates in the negative terminal. That means as more number of electrons come, it becomes negatively charged. Where the hydrogen ions went and reached, that terminal called positive terminal. That's what we are seeing. Why I'm explaining is even BTech electrical students, MTech level instrument control, I have seen in interview for MTech, BTech, PhD. He says that I am basically electrical, I want to do robotics, something like that, or in a automation control system for IC engine. All the people apply, correct? Just like you people. If you ask the electric, how what is the electricity produced, they can't tell except few students. So actually the electrons are produced a negative terminal of any battery, whether lead acid battery, nickel cadmium battery, or this one. The negative terminal is accumulated with the electrons split from the electrolyte. And they are accumulated. As more number of electrons become more, that means zero, initially 0 volts. As more number of electrons accumulated, become 1, 2, 3, but that is minus voltage. Correct? It increases. Simultaneously, positive charge, H plus will go to this one, equal number, correct? So this will become positive. So if I connect a voltmeter across these two, correct? So the positive terminal connected to positive this one, the voltmeter will show deflect like this. 0, 1 volt, 2 volt, like it, depending what is the charge is getting to this one. Okay, that's how it works. So if I supply a voltage to my electric motor, correct? Electric motor, I am showing single turn electric motor shown here. Automatically, what will happen? The current will flow from the positive terminal to negative terminal. That is called as conventional current. But actually, as I told you that the current is nothing but flow of electrons. This is called as electron flow, direction of electron flow. Electron flow only produces current. But somehow in the beginning, some 250 years before, somebody said this is positive, this is negative. So current flows from positive terminal to negative terminal. This is called as conventional current. This still we are saying that. But actual current flow happens from flow of electron from negative terminal to positive, and again it comes circulates again produced, but the electrons are produced by the electrolyte, which split into positive and negative ions. That's what happened. Okay, now that I given this current, because of that, what happens? There's a magnetic flux is created. Okay, so this across this there's a magnetic flux. I'm going to. Okay, so the magnetic flux will be created. Please note that my wire is vertically and current is flowing like this. Then around the wire, because current is flowing from top to bottom, conventional current. So there will be a magnetic flux created in this direction. Correct? In this direction, magnetic. This is governed by how much magnetic flux. The magnetic flux is represented by phi. The unit is Weber per meter square or Tesla, any one of the unit. Magnetic flux density or flux strength is Webers per meter square area, 1 meter square, unit square area, or Teslas. Both are used. Okay. Now, that means how much will be created. This is proportional to I, current flowing. We know that I is proportional to voltage applied when the coil resistance, correct? This wire resistance R is fixed. That's what yesterday also I told. Now, when you this one, then the magnetic field. Now, because this is what we are talking about, one coil. We are talking about one coil. Okay. So now when we talk about motor, I said it has two coils or two magnets. It has two electromagnets and which produces two magnetic fields. Okay. One magnetic field is called as field magnetic field. Field magnet. Okay, I say pi f. Other one is called as armature magnetic field or magnet, whatever we can say. Being electromagnet, it is not magnet, we say magnetic field, right? Field magnetic field and armature magnetic field. This I represented by phi A. And I told yesterday, the torque produced in the motor, I say capital T or Tm is equal to Km multiplied by phi F into phi A. Okay, where the Km is called as motor constant. It is called as motor constant. This will be generally given by motor manufacturer. Motor manufacturer will provide, or there is an equation. Will provide this value. Okay. That means now we know that this is proportional to IF, which is not a field current. This is called proportional IA. This is field current. Proportional, correct? This is proportional. This is proportional to armature current. Okay. Now, actually, since to have some more this one, if you see your DC motor, I'll come back to the figure later. DC motor has three parts apart from field coil and armature coil. For understanding purpose, I will draw this figure. A semicircular these two parts are called brushes. Correct? So these two semicircular parts are called as commutator. Okay. Now, from the commutator, for understanding better, I will take the single turn electric motor. That means from here, there's a wire is going, and from here also, there's a wire is going something like this. This is armature coil. Okay, this is armature coil. Please note that I am giving voltage VE, VA. Okay, this I am giving VA. That means armature voltage is supplied from this power supply. From this, the current will flow through the brush. First, this is I say brush A, this is brush B, and I say A dash is our commutator part, which touches the A, and again commutator part bottom one. Okay, so I say the B dash commutator parts. So the voltage from the power supply, a DC power supply, VA armature voltage is given to the brushes. From the brushes are touching the commutator. The commutator is attached with the coil, armature coil. Please note that armature coil can rotate freely because this is put on a shaft with bearings. Then I have two magnets. Okay. So this is North Pole. This is South Pole. These two forms what we call a field magnet. Please note that in DC motor, just now I told the field magnet also electromagnet, but for understanding purpose, I am showing as a permanent magnet, represented like a permanent magnet, correct? And the field strength, the magnetic field strength is called phi F. So now, since I am supplying VA, there's a current is flowing IA through the coil from the battery to brush A to commutator part A dash, then the current is going through the wire, single turn armature coil, it goes like this, the current IA is flowing and it comes back like this. Okay, it is coming back like this. Again, here it is coming back here. And finally, it comes through like this. This is IA. To commutator part B, brush B finally ends to this is my IA. Negative terminal. So current flows. Because of that, there's a phi. Since current is flowing, phi A is created. Correct? That is called field magnet, armature magnet field things. So we know that yesterday also I just talked to you that the field magnet, correct? Since there's a field magnet, magnetic flux from north to south pole is moving like this. This is what the phi F, correct? This is what phi F. Now it is. Now one magnetic field created by permanent magnet, which is nothing but field magnet with phi F. Other one is we are supplying voltage because there's a current flow because of IA because of phi A. The phi A will vary if IA is varying. This will increase or decrease depending upon IA. If IA is increased, phi A value will increase. In this case, this one. Already we talked about this one. Since there's a single turn is there. Now, if this is like this, what will happen is current is flowing this direction from enters from A, go to top coil, correct? There are two coil. This side, the length of the coil, I'm saying as capital L, that is between this to this, correct? And because this is called as a W, width of the coil. Single turn coil, it has the height WL width, I call it. And because there are two sides, LL same length and width. And this is the center axis. With respect to center axis, I may put different color, blue color. With respect to that, this is one side, this is another side. From here, you can see that width can be W by 2. Correct? The W by total width is W. W by 2 is the one side from the center axis. So now that means the armature will rotate like this. With respect to this, it will rotate omega. This is center axis because I told you there are bearings. Now, for this, we can say that there are two magnetic field, phi F and phi A. They are interacting with each other because there's a magnetic field created. Because current is flowing, correct? That's what I told you. This is what you phi A, the blue color circle, the current flowing. That is called phi A. Sorry, theta A. Phi A because of the theta is there. Now that means this two magnetic phi A will begin because it has north and south pole, correct? They start exerting a force on each other, attracting a repulsive. That force we call as a F. F for the single turn will be given PIL into sine theta, where F is Newton, correct? The force is the force will act like this, correct? The force is acting like this. And so bottom side will be acting in this direction. F will be direct. So because of that, they rotate with each other. Make the armature to rotate because it is freely. So many newtons force is created in single turn. And please note that depends upon angle. This now in this B is the magnetic flux density. It is nothing but pi F. The pi F is nothing but here B represents magnetic flux under the field magnet. B is a permanent magnet. And phi A is going to vary, that depends upon IA. Literally speaking, I can put IA. So IA is nothing but armature coil current. Armature current, I can say. Armature current in amps. Okay. Then you have L. L is but the length of the coil. This is I told you the length of the coil. Okay. So theta is the angle between wire, correct? Wire is wire and magnetic flux. Correct. So magnetic flux is going like this. This is current. The wire is like this because the current is moving in that. So depending upon, because you can see that this coil can rotate. Correct. So as it rotates, the angle varies. Correct. The theta varies because the field may remain constant. But armature coil, because the repulsive force it is rotating, as it is rotating, the theta will vary. But you'll see that the force will remain constant. Okay, the force will remain constant. So the torque is proportional to the radius of the coil. Okay, that we'll see in the next slide. So this is how the basic equation of force produced in single turn is given like this. And we know that in the electric motor, the armature is not made a single coil, it has multiple coil. For example, it has n turns of coil. Please see that I'm talking armature coil. Field magnet is a permanent replaced by permanent magnet having constant field strength, phi f, for understanding purpose. Correct? Number of current. Then F will be equal to N into BIL sin theta. Okay. Now, the torque produced in this one, because rotating force, we call it, because force is produced because of repulsive force, because that armature is allowed to rotate because it is on a bearing. So the torque T is, we know that BIL into omega by 2, sorry, W by 2, because you can see that the coil, you have top portion and also bottom portion. Both sides there are two forces acting. Correct. One force from the top coil, there's a magnetic field which is interacting with the south, this one, pole of the field gun. Similarly, there's a magnetic field here that is interacting with this. There are two forces are created. Bottom side one force and top side one forces. So because of that only, net result is their torque is produced, T is produced. That torque can be calculated using this formula into where omega, W is called as width of the coil. Width of the coil is the total. This one I am talking. Correct? Width of the coil. And into sin theta. What is the current angle of the armature coil with respect to the magnetic field of the field coil and also the wire, direction of the wire. Okay, so into this one, into 2, because there are two sides. Okay, this 2 and this 2 will go away. So we can say that torque T equal to N into BI LW into sin theta. The L is the length, W is width. So this can be replaced by N into BI A into sin theta, where A is called area of the coil. Okay, I is the current, already we know. B is the flux, phi f, or flux density. In this case, we just say flux density phi f. B is nothing but flux density in Webers per meter square or in Tesla, any unit. Then N is the number of turns. If I want more torque, correct, for given this one, I can increase the number of turns. As I increase more, the motor torque will increase. This is the basic equation which provides how much torque is produced in a DC motor. Correct? In a DC motor, this is what we are talking. So now when we talk about DC motor, as I told you,
yes, please. Using this formula, we can expect some problems, huh?
Every formula there can be a problem, because you are going to see more number of this course you have more formulas, more things. So each formula there can be small problems, or this one you can expect. Okay.
Thank you.
Okay, so this is how the basic this one works. And as I told you, the DC motor basic principle works on 3 laws. One is called Ampere law, Ampere's law. The second one is called Faraday's law. Third one is called Lenz's law. Lenz is of all a person's name. Ampere, Faraday, Lenz, who invented. Okay. So what Ampere law says, if electric conductor is placed in a magnetic field, it experiences a force, and if the flow, and as I told you already, I showed that here there's a magnetic field already there, north to south field magnet from coming from north pole to south pole, and there's a current flowing to conductor, this conductor, and because of that there's a force is created. Okay, that force in what direction is governed by Ampere's law. He says that it follows right hand rule. We call right hand rule. That means when I say the right hand rule means, if I say that take your right hand, you have a thumb finger, then you have index finger, then you have other three fingers. Okay, this is your hand, and if this represent other three fingers, each one is perpendicular to each other. This is your hand, correct? This is a thumb, this is index finger, remaining fingers. Okay, and you see that this is 90 degree, between these three also 90 degree. So in if this represents the current I, it represents the thumb represents I, and the index finger represents the magnetic flux or the field magnet, direction of field magnet. This is field magnet direction, this is the electric current direction. Then the force generated will be perpendicular of both these. That's what represents remaining three fingers. They will say this was invented by Ampere. So that means motor works on the principle of Ampere's law. What force created, but the what direction force to be created is given by Ampere's law. If current direction changes, force will act in other way. Okay, so that's how it works. The next one is called, what you call as the Faraday's law. Faraday's law talks about how much force is created. Okay, and it also talks about the, if the current is flowing through a conductor which is placed in a another magnetic field, and or if a wire, I have a magnetic field going like this from top to bottom. Okay, then I take a wire, the wire is moved across this. This is B, this is the wire conductor. If it is moved across this perpendicular to this is direction of motion, right? Then a voltage will be induced in this wire. We call it EMF, electromagnetic. The unit for that is volts, right? Actually, correctly we call it generator produce electromagnetic force. The unit for that is volts, but we always say volt. Generator generate EMF only, and the unit for EMF is volts. So if there's a magnetic field coming from top to bottom direction, and with perpendicular to that, I take a wire. This is my wire, and if it is moved in this direction perpendicular to that, then a voltage EMF is induced. So EMF induced equal to minus N into d by dt of phi. I know that this is a phi, magnetic field represented by phi, and N represent number of turns or length of the wire. It can be length of the wire. D by dt of phi. That means what rate the wire is cutting the magnetic field. Correct? D by dt of wire. That means what velocity. Correct? At what velocity wire is, velocity of the wire cutting and moving across this one, going to decide the voltage. So many volts will be generated. Correct? This was invented by Faraday. So that means in electric generator, working principle invented by Faraday. Correct? Michael Faraday, full name is Michael Faraday. Similarly, the Lenz law. Any motor, whether AC motor, DC motor, any other, these three principles are working. That's why I'm just telling. Lenz law says direction of induced voltage. Lenz law talks about direction of induced voltage in the wire. Okay, that means whether this side will be plus, this side will be minus, or this will be plus, this will be minus. That is decided by Lenz law. Okay, so So these three people invented this. So because of that only, I thought that these three law governs whether it is electric motor, electric generator. These three principles are basic principles based on that we are going to see about it. This is just information. Okay. Now, once we talk about DC motor, already I told you there are the three types of DC motor. I will first start with shunt motor. I say DC shunt motor. Okay. So DC shunt motor is represented like this. Symbolically represented like this. Take down. So this is nothing but armature. This is the whole thing is called armature, symbol for armature. Okay. So this is the symbol for armature. In electrical book, if you see this, you can say that this is motor, generally represent armature. This is nothing but field coil. And this is the supply voltage. V supply, correct? So, as I told you, sometimes you can have two separate voltages. And for armature voltage, we have to supply VA. For field coil, we have to supply VF. That means you can have something like some books, they show like this also. Shunt motor, they may show like this. This is field VF plus minus bigger DC voltage. This is IF. This is the field coil. Okay. So 5F is created. Nearby, they put one more your generator, that is armature symbol. We're close to that, and they may show like this. Okay, so exactly plus minus. This my VA, this is my IA. So there will be a 5A. So this also represent shunt motor, correct? But sometimes some books they represent, so for understanding purpose, they say that single power supply. But what you need is two current sources. One current is flowing. This is my IF. This is my IA. And armature has resistance RA. And field coil has a resistance RF. Okay. And this is supply voltage, I say VS. Same power supply, DC power supply is applied same voltage because this is called a parallel connection. Correct. So I can have two separate voltages of VF, VA, and this may be 100 volts. This can be 50 volts. Okay, because there are two power supplies. But finally, what is the torque produced in this one? Torque is proportional to phi A and phi F in DC motor. And what is proportional constant? I said T, torque produced or TM motor torque equal to Km multiplied by phi A into phi F, where Km, this proportionality constant, they're called motor constant, correct? And in this case, because I can have different current, we know that IF is proportional to VF divided by RF, IA is equal to VA divided by RA. By having different voltages, then I can vary different this one. I can have different IA, different IF. So my phi F also can be different. Controlling is easy, correct? Phi F, IA can be controlled because I have two different sources. So that means the torque produced by your DC motor, TM, can be controlled by controlling voltage applied to armature coil or voltage applied to field coil. Correct? For given number armature resistance and field resistance. Because RA resistance, number of already you had made a motor. I say that my RA equal to say 10 ohms and RF equal to 5 ohms. Already motor is made. And only thing, what is the that means in this formula, RF is fixed, RA is fixed. Only variable possible is IF is proportional to VF, IA is proportional to VA. And net torque TM equal to phi A and phi F. Phi M, phi F proportional to IF. Already we know that. Correct? So that means I can, to control the torque produced by motor, if this is called separately, another name. Correct? In some book, they call separately excited shunt motor. Separately excited shunt motor. one advantage is I can vary the VA, VF or VA independently or together. Finally, I can control torque of the motor. But in this case, if I vary V, supply single power supply, if I vary this voltage, for example, 0 to 100 volts, same voltage applied across both the coils, field coil and also armature coil. And under I say that my RF equal to 5 ohms and RA equal to 10 ohms. I know that IA equal to, for example, right now I'm giving 50 volts. 50 divided by 10. That means 5 amps current is flowing. But at the same time, my IF is going to be 50 divided by 5, 10 amps current is going. Correct? Because same voltage you are applying. That means the control is not good compared to separated, correct? Separately excited shunt motors. Okay. This is for understanding purpose. So we will, for now, right now, for our purpose, we'll leave this separately. We take this picture. That picture alone you can note down. So this I'm going to remove. So for understanding purpose, we will use this figure. Okay. Okay. So you leave my supply voltage and I am going to use this. Now, since I supply V supply is applied, and in the another thing what to do in motors, especially AC motor, specifically in DC motor, you will hear what you call as back EMF, which is generally referred VB. Please note that voltage is sometimes in some book they refer ES, supply voltage, or just E. Back EMF represents EB. Correct? Different books use a different convention. I am trying to use my convention, general voltage refer V. Subscript to S means supply voltage. Correct? So B means back EMF. This is supply voltage. Okay. Supply voltage refer VS. Back EMF is produced in the rotating armature only. Rotating or moving armature coil alone, not in field coil. Okay, that you should note down. Okay, so why this? Just now I told you what the Faraday law said. Faraday law says that if there's a magnetic field having some flux density which is flowing from top to bottom, and wire is taken, coil which is moving perpendicular to this direction, automatically a voltage is induced. That voltage is proportional to the number of turns multiplied by rate of. This is called Faraday's law. That means this is the basic equation for generator. Correct? Electric generator work, how much voltage is produced is governed by this equation. Who invented? Faraday. So because of that, what happens? Already I told you, I have a field magnet which is fixed, which is not moving. The armature coil is rotating inside the field magnetic. Correct? So, and of course, the armature coil also produces its own magnetic field because I am supplying a voltage. There's a current flow and it produces phi A because the current flow. This, apart from that, the armature coil is rotating inside the field magnetic field. That means the armature wires are cutting the field magnetic. Phi F will be cut by these wires. Correct? So because of that, another voltage is induced in the armature coil. That voltage is called back EMF because the polarity of the voltage produced in the armature. Correct? The polarity of EMF generated is 180 degree out of phase of the applied voltage is 180 degree out of phase of applied armature voltage. Please note that we are applying armature voltage. because of there's a armature current, there's a phi A that is interacts with the field magnet, repulsive for the motor will not work. So to make the motor work, we need to supply a voltage to armature coil. We need to supply a voltage to field coil. So this produces phi A, phi F, and they interact with each other. So because the torque is created, but the field coil is fixed on the body of the motor, it cannot rotate. Armature is allowed to rotate because the armature itself is on the bearing. So it rotates. While it rotates, it cuts the phi F, the field magnetic coil, because of the voltage is produced. That is governed by the Faraday's law. So which is called a back EMF, because the polarity of this voltage will be opposing to the voltage applied. So that means now that we applied the voltage, supply voltage to both this one, and we can write a voltage equation, which is called Kirchhoff's voltage equation, KVL, which is called as Kirchhoff's voltage equation.
Sir, 1 minute. Sir,
Yeah.
Sir, we are noting. Sir, can you go to the previous lecture?
Yeah, definitely.
Sir, this POT, what is the potential? Potential of EMF?
Potential, no, polarity.
Polarity. Okay.
Sorry. Polarity of the EMF generated is 180 degree out of a apply voltage. Apply voltage is we say that VA, armature voltage represents this one. This voltage is called VB. VA will be applied voltage or armature voltage. We know that VB is generator voltage, back EMF. The polarity of this voltage will be opposite. Okay, that way it will oppose. So now according to KVL,
Okay,
we can say that VS, correct, supply voltage will be equal to VB plus IA into RA, where IA is the armature current, IA is this one. This voltage called VA, voltage across the armature coil due to the current flow, correct, according to Ohm's law. So this is supply voltage and this is back EMF. If I add these two together, it will be equal to VS. Okay, so I can write this V supply equal to VB plus I total minus I shunt into RA. Okay, you may be suddenly, sir, you are writing I total, all this thing what we are doing. So let me go back here. This current is called I total. Battery, there's a VS, because of that current. This current produced supplied by battery total V is divided in two parts. One is called as I shunt. Correct? This is called shunt current, and the remaining go to IA. I total equal to I shunt plus IA. Okay. So from the battery, current goes at this point. One portion of current goes to this coil. We call that shunt current, I shunt, and the remaining current goes to armature coil. So that is called armature current. That's what we are talking. So I can write this I total, which is nothing but I supply from the battery, equal to I shunt plus IA. Okay, and we can note down I shunt equal to V supply divided by R shunt, where R shunt equal to shunt coil or field coil or shunt coil. Please note that here in shunt motor, the field coil is called a field coil or shunt coil, both name, field or shunt coil. Coil resistance. Okay, so because of that only, from this you can write this equation. Okay, so we are supplying in now in normal working condition. The V supply will be held constant, Okay, will be held constant. And already I told I shunt equal to, sorry, I can write equal to itself, V supply divided by R shunt. This also will be generally held constant. Okay. Okay. Since the I shunt is held constant, I say that phi is or phi f or phi shunt will be constant because this is proportional to I shunt. Because I shunt is kept constant because the V supply is constant. R coil also held constant. Automatically, shunt current will be constant because of the shunt magnetic field. I shunt or phi will be held constant because this is constant. Okay. Now we wanted to find out how much will be the back EMF generated. V back. I say V back EMF generated in DC motor armature coil because which is rotating. Back EMF generated in armature coil only VB is proportional to this equation 60A into VS divided by P into Z into phi. Okay. Or I can say phi shunt because we are using phi shunt. In some books, the field coil will be just represent just phi. Okay. They will represent instead of phi shunt, they will represent just phi. In that case, you will see the equation equal to 60A into Vs divided by Pz into phi, just phi. And since we are using phi shunt for understanding purpose, we'll use that itself. This is what is the back EMF generator in this one. So, and please note that no. Yeah. Okay. Small mistake. Extremely sorry. Not big this one because this equation is meant for motor speed. Okay. This equation is meant for motor speed. What will be speed of the motor for given voltage? I represent by capital N. Capital N, a motor speed, capital N is nothing but 60A into V supply divided by P into Z into phi shunt. Okay. What about the back EMF? The back EMF VB equal to P into phi shunt into Z into N divided by 60A. There are two equations note down because you can expect simple problems. Okay. For a DC shunt motor, resistance is given this much, correct? Shunt resistance this much, voltage, supply voltage this much. Then P, we are going to say about P represent number of poles, Z represent number of parallel paths in a DC motor. Because in case of DC motor, it will not be one single coil. There will be n number of coils as a one bunch. That is called as one parallel path. And in bigger motor, if you want kilowatts, megawatt, you will have multiple bunches of coil connected parallelly and supplied same voltage. So that is called number of parallel path. That's what they represent Z. It can be 2, 6, 4, 8, something like that. And the number of turns will be different. Okay. So note down this formula. So this is equation number 1. This is main equation I'm talking because all the equations are important, but these two are the main equation which talks VB. Okay. And
so one minute, sir. We note it.
Yeah.
Sir, what is it, sir?
Yeah. I will tell that. It is called number of conductors in one bunch, and A represent number of parallel paths. Z represent number of conductors. This will be given.
And sir, this motor speed is in what quantity, sir? Means RPM or
Yes, RPM.
RPM, because this we are talking into 60A, no? It is represent number of revolution per minute, RPM.
Okay. Thank you, sir.
Thank you.
Okay.
Sir, we know.
Yeah. So right now, then let me tell what this are. Z is called number of parallel conductors. Then P is called number of poles. Okay. N represents speed of the motor. Speed of the motor, and phi represents flux density per pole.
Sir,
Density.
sir, one more.
Yeah,
What,
please,
sir?
please.
Sir,
Yeah.
A is ampere or something, sir?
No. A is called a number of parallel paths. A is called number of parallel paths. That means in bigger motor we are talking, bigger motor, 1 kilowatt, 10 to 100, 1 megawatt, 10 megawatt, big motors are there. You will have more number of parallel paths. One set of, you can see number of conductors in one parallel path. Like that, you will have A. That says, say 100 coils or 50 wires in one bunch. That is called, correct, number of turns. Such bunches will be there, so 5, 10, something like that is a number of parallel paths. But generally, parallel path will be two-fold. There's a fixed. In designing DC motor, there's a fixed. Generally, we give the value number of parallel paths. A represents number of parallel paths. No doubt. Z represent this one. Okay. Let me clear it. You can write down clearly. A represent number of parallel path. Phi represent flux density per pole. It is generally given Webers per meters per Tesla. N represents speed of the motor. Z represents number of conductors per path. And P represents number of poles. Please note that we are talking here. For example, this motor I am talking about two poles, correct? North pole and south pole. Generally, in case of motors, it can be like this. Correct? So this is pole 1, pole 2, pole 3, pole 4, and inside that you have the armature. Correct? Okay. Armature will be generally represented like this. Let me show that. That's how it is represented. And it is rotating, correct, with respect to. So we say P4, P1 and P3 represent one pole. This is north pole, this is south pole, correct? So similarly, this is south pole, this is north pole. Okay, so this is one pole pair, this is another pole pair, correct? In the people talk of pole pair, correct? Another one is poles. Number of poles here is 4. Number of pole pair is 2. Correct? That means 2 pole pair division. Here, in this case, we talk number of poles. The P represents number of poles. Okay. So once, if there's a problem, correct? In the exam, you for your DC shunt motor, correct? For calculate torque, calculate the speed, calculate the back EMF, where we'll give these values. Correct? A is given, phi is given, N, Z is given, correct? Then P is given, number of poles. Then you need to calculate then phi shunt, correct? Phi shunt can be calculated using this equation, correct? You can see that phi shunt is calculated using this one, our value will be given. Okay. So once they're given, you can always calculate this one. Finally, before concluding, because I want to start the time up, and I want to at least complete this, the torque produced by DC shunt motor. I say that DC shunt motor is given by equation PZ phi shunt into IA divided by 2 pi A. Correct? Sometimes this will be called as some book, this will be called as TG, that is nothing but generated torque. In some book they call it TG or TM, motor torque. All are same. Correct? Because this much amount of torque is produced in the armature, but the shaft is then they say is T shaft. T shaft will be always lesser than TG. Why? Shaft is, I have the motor, from that there's a shaft is coming out, I connect it to load, correct? So here I have bearings, there are friction, correct? There are bearing friction, all these things, motor side, load side, all these things. So frictional losses happens. Because of that, the TG, the load torque will be always, supply to load will be always lesser than this one. I say that TL will be always lesser than TG because of frictional losses. So that what we are calculating here is the generator torque or motor torque or T shunt motor torque. Okay. Yeah, otherwise what? So finally, before just closing, I just want to say that to derive the torque, how to derive the torque? Because we know that the motor input is electrical voltage, correct? Electrical power is given as an input and mechanical power is coming out of the motor. This is my motor, correct? Mechanical power. I say P mech, P electrical. And that means if I give to a motor is going to produce this. Okay. So what is the input power given in this motor? Vs into I, correct? Actually, IA. Vs into IA. 1 minute. I just want to what we are used. We will see that. I think we use IT, no, total. Yeah. So the current given, this is Vs into IT. This is total I thought is the supply from the battery. You can see here. Correct? IT is given. This is supply voltage. In electrical thing, voltage in the current is going to be the power supply. That is converted into mechanical TG torque into this one. So this is equal to Vs into I total equal to VB into IB plus IA square into RA. Okay. Where this is called as electrical losses in coil. Sometimes they call it copper loss. Another name for this called copper loss because wire is made as a copper wire as a resistance. If current flows through that, some amount of energy will be wasted as a heat. That is called I square loss. This is going to be generated heat and will be wasted in the motor coil. This is the vacuum. Okay. So the mechanical torque or mechanical power equal to TG multiplied by omega. Okay, TG is generated torque, omega the speed of the motor, radians per second we can do this one. So we know that VB into IA equal to T into omega. Okay, since why we are talking VB into IA is the field coil is going to remain constant, correct? It is not going to be. Basically, the VB is going to vary. VB is proportional to speed. Correct. Already we saw the equation VB is proportional to speed. Correct. For all other things are constant. Note down that. You can see that in this formula, VB, P is fixed. For example, 2 poles, 4 poles of thing. This is also fixed. Phi shunt because coil distance is fixed and voltage is fixed. Z is fixed. Correct. And A, number of parallel paths is fixed. 60 is a constant. So that means I can say that VB is proportional to N. N is nothing, speed of the motor. When motor is a rest condition, VB is 0. As the speed increases, VB increases automatically. That's what happens. So that is very important point to be noted down. I will stop here. Okay. Tomorrow, we will see about the series motor and shunt motor characteristics. And then we will see about compound motor. Okay. And after that, we'll go to AC motors. Induction motor and synchronous motor, which is used in electric vehicles.
Okay,
Any
sir.
questions? Otherwise, I can stop. I know the time little up. I took another 15 minutes more. Sorry.
No problem. Thank you, sir. Thank you.
Okay. Thank you. Good night. Give your attendance before leaving. Yeah.
Thank you, sir.
Thank you, sir.
Yeah.